This is the deep sea anglerfish. There are over 200 species of the deep sea anglerfish, but all have a few things in common. To start, they all have the same classification, that is, kingdom Animalia, phylum Chordata, class Actinopterygii, and order Lophiformis. Most live a few miles down in the lonely, completely lightless and desolate habitat of the Atlantic and Antarctic oceans. Some, however, live in shallow, tropical environments. Some can be quite large, reaching 3 feet in length. Most, however, are less than a foot in length. Most are dark gray and brown in color, but they all have a fleshy growth on the head that ends in a bulb, or at least all the females do. This is a female anglerfish. A piece of dorsal spine called the iliceum protrudes above her mouth and ends in a bulb called the esca. This long, fleshy growth acts as a lure, because it's not just a bulb, it glows. The female anglerfish specializes in bioluminescence. Bioluminescence is any flashing light created by animals. In this case, light is generated by bacteria that lives permanently inside and around the anglerfish's esca. Bacteria enters the esca through small pores, then multiplies until the density of the bacteria is such that they create a collective glimmer. It is the esca that gives the anglerfish her name. Anglerfish use their lures in a way that is very similar to the way fly fishermen use their flies, except instead of using strings and bait, the anglerfish uses bioluminescence. All anglerfish are carnivorous. However, in the lonely and dark depths of their habitat, food can be hard to come by. An anglerfish's lure ensures that when the food is nearby, she can attract her prey to come to her.
I see a light.
A light?
Yeah, over there. Hey, Conscience, am I dead?
No, I see it too. What is it?
It's so pretty.
I'm feeling happy, which is a big deal for me.
I want to touch it.
Ooh. Hey, come back. Come on back here.
I'm gonna get you.
I'm gonna get you.
I'm gonna get you.
I'm gonna swim with you.
I'm gonna get you.
I'm gonna be your best friend. Good feelings gone.
In the blackness of their habitat, this bioluminescent glow attracts unsuspecting prey toward the anglerfish's really, really big mouth. The lure is just one example of the angler's many ecological niches. Her enormous crescent-shaped mouth takes up the majority of the front half of her body and is filled with sharp, translucent, backward-facing teeth. In fact, her teeth are so large that her mouth can't even be shut properly. Since prey is so hard to come by in the deep sea, the angler needs to be prepared to eat, even if the prey is bigger than she is. She can ensure her next meal through her ability to depress her teeth, distend her jaw, and expand her stomach. In addition, her bones are thin and flexible. All of this ensures a smooth passage to her stomach and the ability to swallow anything that can physically fit in, even prey up to twice her own size. Researchers suggest anglers minimize their energy use between meals by employing a lie-in-wait hunting strategy. Anglers are actually able to hunt and forage while remaining lethargic, devoting just 2% of energy intake to swimming. A study by Lonnie Ludson at the Monterey Bay Aquarium Research Institute found that anglers are more likely to drift or crawl along the ocean floor instead of swim because it is more energy efficient, less disruptive to surrounding waters, and therefore less likely to scare off prey. The anglerfish is only capable of this lazy hunting method because her lure allows her prey to come to her instead of the other way around. Evidently, the angler's lure is pretty effective in helping her hunt. However, the lure isn't just used to find food. An angler's bioluminescent glow helps attract both prey and mates. Yes, mates plural. All anglerfish follow a polyandrous mating system. Reminder, this is a female anglerfish, and this is a male anglerfish. Female, male, female, male, male, female. Notice any differences? For starters, the male anglerfish doesn't have a lure, and it's significantly smaller. In fact, the male is just 1/10 of the female's size. The male anglerfish is actually the smallest vertebrate, but most biologists don't count it because it relies on sexual parasitism to survive. Yes, sexual parasitism, another one of the anglerfish's many ecological niches. Because a male anglerfish doesn't possess a lure, he eats only whatever small fragments of edible matter he can find. This only lasts for the early stages of his life, though, because when he reaches sexual maturity, his digestive system starts to disintegrate. His sole purpose in life becomes not to feed, but to find a mate. He uses his extremely sensitive sense of smell to detect the pheromones of a female and hunt her down. Once he sees her bioluminescent glow, he approaches her and he bites her, and he doesn't let go. After attaching himself to her, he releases an enzyme that starts to digest the skin of his own mouth and the skin of her body. This fuses the two together down to the blood vessel level. As he decomposes, he no longer has a digestive system, and he relies entirely on the female to sustain him. But why? This is yet another adaptation of the anglerfish in response to his lonely habitat. One crucial detail about the male's decomposition: all of his internal organs decompose, except for his testes. Now, whenever the female wishes to reproduce, she has her own supply. She no longer has to wait for a male. A single female can have dozens of testicles hanging from her. All of the angler's ecological niches, from eating habits to sexual parasitism, are due to the difficulty of finding a mate and a food source at the bottom of the sea. When a female finally does find a meal, she needs to be prepared. And when a male and a female finally do find each other, they need to stick together. Literally. Because the anglers live so deep, there is little research about the deep sea creatures beyond their reproductive habits. However, the Monterey Bay Aquarium Research Institute was able to record one of the first videos of an anglerfish as it swims during a study in November of 2014. Bruce Robison, Research Division Chairman of the Aquarium's Research Institute, and his team are researching the possible impacts of temperature change on animals in the deep sea. You can see that the temperature is creeping up slowly, probably because of global warming, Bruce Robison said. If the temperature continues to rise and the amount of oxygen continues to decrease, things are going to change. Hopefully, however, biologists can conduct more studies and learn more about the deep sea angler before it's too late, because it really is a fascinating fish.